Good morning, everyone. I'm back. Welcome to today's class. I'm going to be helping you through some algebra problems again. My name is Marlyn. I'm an undergraduate student at the University of Waterloo studying chemical physics with a math minor. Let's get into it. Okay, so for our first question, we want to solve so negative 5 over 8w equals 15, and we want to isolate for w. So first we can begin by multiplying both sides by 8. So we get negative 5w is equal to 15 by 8, and then we want to divide out this negative 5. And this goes 3, negative 3. So w is equal to negative 3 times 8, and that would give us 24. So w is equal to negative 24. Okay, so we want to know how to solve x squared plus 10x is equal to 3 by completing the square. So we know that in order to get, we want to write this in a form of x plus a squared minus a squared is equal to 3. And that's purely because x plus a squared would give us x squared plus 2ax plus a squared, and we want that 2ax to be 10x, and then we subtract off the a squared in order to cancel the extra number. And so we want 2ax to be equal to 10x. Let's just cancel out those x's. So 2a is equal to 10, which means a is equal to 5. And so now that we know a is equal to 5, we get x plus 5 squared, and that would give us x squared plus 10x plus 25. So we want to subtract the 25 in order to just remain with this is equal to 3. And so we take it over, and we get x plus 5 squared equals 3 plus 25. That's going to give us 28. And let's just take a note that 28 is equal to 4 by 7, which means that when we square root both sides in order to get rid of this squared, we get the square root of 4 multiplied by the square root of 7. And this would give us plus or minus 2 square root 7. So x1, let's take the positive. So 2 root 7 minus 5. For x2, we take the negative. Negative 2 root 7 minus 5. Perfect. And that is the solution. Okay. Now we want to use the quadratic formula to solve this. So let's just write it out. And we need to know what the quadratic formula is. So if we have a quadratic like this, we have x is equal to negative b plus or minus b squared minus 4ac over 2a. And now we just put in our values. So we know b is equal to 4, so negative 4 plus or minus b squared, that is going to give us 16, minus 4 by 10 by 2, all over 2 by 2. So negative 4 plus or minus 16 minus 80. So root negative 64 over 4. Let's just rewrite that as negative 4 plus or minus root 64 multiplied by root negative 1 over 4. And this becomes negative 4 plus or minus 8 I over 4. And this is going to give us negative 2 plus or minus, negative 1 plus or minus 2 I. And so we get x1 is equal to negative 1 plus 2i. x2 is equal to negative 1 minus 2i. And let's just make a note that I is equal to the square root of negative 1 for those who are not aware. And those are our answers. Okay, we want to know what equation demonstrates the additive identity property. And so we need to know what that is, of course, and it simply states that a plus 0 is equal to a, and this equation can of course be written in two forms, which is a minus a is equal to 0. Okay, so if a is equal to 7 plus 4i, that means we can write this equation in two forms, and that's 7 plus 4i plus 0 is equal to 7 plus 4i. Additionally, we can write it in this form too, and that's 7 plus 4i plus negative a, so negative 7 minus 4i let's just rewrite that. Is equal to 0. So these are our two equations. Let's just see if we have them anywhere. And we find that this one is b, and that this one is d. So both b and d demonstrate the additive property. Okay, let's move on to our next question. So if f of x is equal to x squared minus 2x and g of x is equal to 6x plus 4, find the x that would evaluate as such. Okay, so this is the same thing as writing f of x plus g of x equals 0. And so we're just going to add these two. So x squared minus 2x plus 6x plus 4. So our f of x and our g of x is equal to 0. Okay, and we're just going to simplify this equation. X squared plus 4x plus 4 equals 0. And we know that when we have x plus a squared, we get x squared plus 2ax plus a squared. And so we want a squared is equal to 4 and 2ax is equal to 4x, which means 2a is equal to 4. And that gives us a is equal to 2, which means that this equation is solved by x plus 2 squared, which means that we have one solution, and that is at x is equal to -2 with a multiplicity of 2. And that's because it's technically x plus 2 multiplied by x plus 2. That's our final answer. It's actually just take a side note with this problem, and that regards how we solved it. We noticed that 2a should be equal to this, and a squared should be equal to this. And so if we had ax squared plus bx plus c, we can also solve it by having a product sum table, and we want the product to be a by c and the sum to be b. And so we want, with this equation, the sum to be 4 and the product to be 4, and that can be done with 2 and 2. So the solutions to the equation become x plus 2, x plus 2. The two solutions here, you put them in exactly as they are. They are not the x is equal to your zeros. And so the actual solutions are x is equal to -2, as we just discussed. But that only works if you have a scenario like we did above. Okay, so if f of x is equal to x squared minus x, f of 2x is equal to question mark, and we know that whatever we put in the brackets, we just replace x with. So if you wanted f of u, that would be u squared minus u, which means that f of 2x is equal to 2x squared minus 2x. Let's just simplify that to 4x squared minus 2x, and we can simplify that further to 2x into 2x minus 1. And this is our final answer. On to the next problem. Okay, so we want to factor 8x cubed plus 27. When they say factor and there tends to be a cubed, it means that you're using the difference of cube or sum of cubes rule. So it's either sum or difference of cubes, and let's just write those out, and we get a cubed plus b cubed would be a plus b, so the same sign here, and then a squared minus ab plus b squared, the opposite sign here. And let's just repeat that. A minus b, same sign, a squared plus opposite sign, ab plus b squared. Okay, so now we want to write this in a form where it's a sum of cubes. Okay, so we know 8 is equal to 2 cubed. X cubed is of course equal to x cubed, and now we want to find 27 is equal to what cubed, and you can simply find that by taking the cube root. And you should get 3. Which means that if we express it in cube form, you get 2x cubed plus 3 cubed. So this becomes our a, and this becomes our b, and we will be using this first one. So it becomes 2x plus 3, 2x squared, and that would be equal to 4x squared. So 4x squared minus 3 into 2x, which is equal to 6x. So 6x plus b squared. B is equal to 3, so b squared is equal to 9. And this is our final form for a factored version of 8x cubed plus 27. So there's just a slight error in the solution, but otherwise it's correct. Okay, so this is where we get problems that are a little more interesting. Okay, so we want to solve is greater than -8. Okay, so we need to remember the standard form of the equation for a line, and that would be y is equal to mx plus b. So if we have y is greater than mx plus b, this means all points above the line. And so, but not including the line, because the inequality isn't an equal sign, it's greater than. So if the line looks like that, for example, then we would typically draw a broken line instead to show that we are not including the line, and then you shade everywhere above it. This is above and that's below. Okay, if we have Okay, if we have y is greater than or equal to mx plus b, when we draw it, we do include the line, and it's all points above and including the line. And that's because it's greater than or equal to, and when it's equal to, it is the line. When we have y is less than mx plus b, it would be similar to the first one. So if this is the line, we draw it broken, and now we want y is less than, so it would be all points below but not including the line. And that's because y is less than but not equal to. And then lastly, we are going to have y is less than or equal to mx plus b. And now we will include the line and all points below it because y is less than or equal to, and when it's equal to, it is the line. Okay, so now knowing all of this, just move on here. When we have 4x plus 2y is greater than -8, let's isolate for y so we can get it in one of these four forms. And so we get 2y is greater than -8 minus 4x, and then we just divide out the 2, which means y is greater than -4 minus 2x. And so that would be in the form of equation 1. And so we now need to draw what that line would look like so we can highlight all points above, or in this case, yeah, above it. Let's just write it up here. Minus 2x, and that would intersect at -2, 0, 0, -4. And you can get that by just solving. If you just put in x is equal to 0, which is this point, which is, yeah, this point, and y is equal to 0, which should be this point, and just connect them. And then we want to highlight all points above it, but not including it. So that means a broken line on top of it to show that we are not including the line. And then we just highlight all points above it by shading as shown. And that is the solution to the problem. Okay, so again, we're going to be graphing another inequality. So let's just rewrite those. Including the line, and finally y is strictly less than mx plus b. So for these ones, as we said, it would be broken lines. And y is less than, so below. This one is again a broken line because of the inequality and above. Okay, so for this problem, we again want to isolate for y. So it's less than or equal to 4. So let's move this 2x over here, and we get y is less than or equal to 4 minus 2x. And so the inequality we have is in the form of the third one. And we just need to graph the line. And when you plug in x is equal to 0, you get y is equal to 4. And when y is equal to 0, x is equal to 2. So let's just plot that. And we know it would be all points below and including the line. So let's just shade that. And so on the graph, I'm not sure if he shows it here, you can just put it into Desmos and it'll show you the exact same thing. So it'd be all points in this 2D space that are below this line. Okay, so we want to find the polynomial with zeros at x is equal to 0. So this means that that would just be x. X is equal to -2, which means x plus 2 is equal to 0, and x is equal to -3. And that means x plus 3 is equal to 0, which means f of x should just be the product of these three. So let's just write that down here. Oh no. Yep. And so we write that out. Let's first write this out, and that becomes x squared plus 2x multiplied by x plus 3. And then we can carry out some FOIL, so x squared, x plus 3 plus 2x, x plus 3. This is going to give us x cubed plus 3x squared plus 2x squared. Plus 6x. And that's x cubed plus 5x plus 6x. And this is f of x, and that's just the product of the function zeros. Okay. So we want to find out which one of these has x is equal to -6 as the solution, which means that we have to find x in all of them by expressing them using exponential form. And so we just need to remember exponential form states that log base a of b equals to c, expressed in exponential form would be a, c is equal to b. And so a would be equal to the seed root of b. Okay, and so let's try a first. So log x 36 equals 2 can be expressed as x squared is equal to 36, which means x is equal to the square root of 36, which is positive or -6. But if we put in a negative base, the function would be undefined. So the only x that would be allowed here would be x is equal to +6. And so this is not the answer to our question. Let's try B. So log 3 2x minus 9 equals 3. That becomes, you just pump the base over there, 3 cubed is equal to 2x minus 9. And that becomes 27 is equal to 2x minus 9. Let's just isolate for x, add 9 to both sides. So 36 is equal to 2x. Divide out the 2, and so we get x is equal to 18. So let's just write all of our options here. So we know it's not A and it's not B. Okay, on to the next one, C. And that one just states that log 3 216 is equal to x, and we can just put this in the calculator for what it is. Expressed in exponential form would be 3 to the power of x is equal to 216. You will find that when you plug it into the calculator, x is equal to 6, but +6. So again, this is not the solution that we're looking for. And that leaves us with D. Okay, so D states log base 3 -2x minus 3 equals 2. Let's express that in exponential form so we can solve for x. So this would be 3 squared equals -2x minus 3. 3 squared is 9 is equal to -2x minus 3. Let's move the 2x here so we can make a positive and the 9 to the other side. And that becomes 2x is equal to -3 minus 9. 2x is equal to -12. Divide out the 2. X is equal to -6. So this is the solution that we're looking for. So the correct answer is D. Okay, we are going to demonstrate the FOIL method on the example of x plus 3 all to the power of 2. Okay, so as I mentioned earlier, the FOIL method is just a quick way of remembering how to expand out these functions, and x plus 3 squared is x plus 3, x plus 3. So it'd be x multiplied by x plus 3 plus 3 multiplied by x plus 3. Now using FOIL, the quick way to remember it, we would express that as x plus 3, x plus 3. So this is first outside, followed by inside last, and that is what FOIL stands for, obviously. And so it's x multiplied by x plus x multiplied by 3, so x by x plus 3, plus 3 multiplied by x plus 3 multiplied by 3, so plus 3 by x plus 3. And so when we write that out, we get x squared plus 3x plus 3x plus 9, and that becomes x squared plus 6x plus 9. And that is our final answer. Sorry about that. Okay, so we want to solve this using the quadratic formula. The quadratic formula is often the best way to solve it because we won't always find that we have two real solutions, and depending on the value of, so let's first write down what the quadratic formula is. So for ax squared plus bx plus c is equal to 0, the quadratic formula would state that x, our first one, and our second one, so the first one is when you take the positive, second one is when you take the negative, is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And so you can have multiple situations come out of this. So you can either have two real solutions, and that would be in the scenario that this is greater than 0. And you can either have two integer solutions, which is what you will most often get, or decimals, which would be hard to find using the other methods I've shown you, like product sum, or splitting up the equation in order to find a way to solve it. Or you can get one real solution, and this would be, in this scenario, the discriminant. So the discriminant is equal to b squared minus 4ac is equal to 0. So two real solutions is for d is greater than 0. And 3, you could get two complex. So two, let's just write it like that, complex valued solutions. And so if d is less than 0, you're going to get some number multiplied by -1 here. Usually the number will be a perfect square. You can get the square root very, very easily, like it's 4, 64, and you can just bring it out and then multiply it by I, which is the square root of -1. And so the quadratic formula will always give you an answer for a quadratic equation, while the other methods may get complicated depending on what the zeros are. So if you can't easily solve it, just go straight for the quadratic formula. Okay, so we're going to solve this using the quadratic formula, and then we can do another method. And so we have x squared minus 7x minus 5 is equal to 0. In this scenario, b is equal to -7. Negative over negative is positive, so 7 plus or minus the square root of 7 squared, which should be 49, minus 4, 1 by -5. So having a negative in this last position, or in the first and not in the last, will often give you two real solutions, and 2 by 1. Or you could just simply get that this product is less than this. In the scenario that this is greater than this, then you do get complex valued solutions, as d would be less than 0. And so let's just calculate that quickly. And it becomes 7 plus or minus the square root of 69, because this becomes 20. -20, and negative is positive, over 2. This cannot be simplified further. And so you get x1 is equal to 7 plus the square root of 69 over 2. And x2 is equal to 7 minus the square root of 69 over 2. So this is the scenario where, yes, the discriminant is over 0, and you have two real solutions. But they're decimals. So this would have been hard to find had we used the product sum method, because we would have a product of -5 and a sum of -7. And that isn't easy for us to find, because 5 can only be written as 5 and 1, and the sum of that is clearly not 7. So the answer would be a decimal, and you can find it using the quadratic formula.